So here we go. Here's number 2. Suppose that the age that children learn to walk is normally distributed, mean 13, standard deviation 2.5, 35 randomly selected people, asked what age, round it to 4 places. All right. Here we go. So the first thing they want you to do is they want you to put the mean and the standard deviation. What's the mean? It is right there, 13. Standard deviation, 2.5. But now for the next one, they're talking about X bar. So that's the average, right? That's the average for a group. That's going to be the same mean, but then the standard deviation is going to be 2.5 divided by the square root of 35, because 35 is the group size. So I'll do that on my calculator. And I'm getting 0.422577. So that rounds to 6, 0.4226. And then question C says, what is the probability that one randomly selected person learned to walk when the person was between 12.9 and 13.5 months old? So we're talking about, how old people are when they learn to walk, typically, right? They're saying the average is 13 months when they learn to walk, but there's a little deviation, right? Some do it quicker, some take a little longer. And if they grab 35 people and find out what age they learn to walk, what's going to happen? So here we go. So question, what is the probability? Now in question C, notice it's 1. 1. So n equals 1 right there. So that's going to be normal. In fact, let me just move it right over here. So for part C, n equals 1. So it's going to be normal CDF, and they're going to go lower, which is left, upper or right, mean, and standard deviation. So lower, upper, mean, standard deviation. Well, they say between 12.9 and 13.5. So 12.9, 13.5. The mean is 13, standard deviation 2.5. Hit the buttons on your calculator. And then for part D, it's almost exactly the same, but now we're talking about for 35 people, the average. So now we're talking about for 35, last part C was for 1, and so otherwise it's the same thing. So normal CDF, lower or left, upper or right, mean, standard deviation. Okay, so what is the lower? Same thing. These numbers are the same, except for the last one, right? The standard deviation becomes 2.5 divided by the square root of 35. That's the only part that's different. Hit the buttons on your calculator. You'll get the answers to those two. And then I'm going to go on to part E. So for part E, it asks the question, is the assumption that the distribution is normal necessary? Do you have to have it? Do you have to know that the distribution is normal? What's the answer there?
No.
Right. And why do we not? Why is it no?
Because it's over 30.
That's it. Yep. Good job. It's no because it's more than, or it's 30 because it's 30 or more. It's no because 30 or more, right? So whenever you have a group of size 30 or more, you don't need the assumption of normality. You've got it automatically. For a big group, they've got to be normally distributed. The averages do. The averages of groups 30 or more have to be bell-shaped. So that one's a no. You don't need it. If now, on the next problem, they're going to give us a group size less than 30. So our answer to that question will become yes at that point. Okay, because then we would need it. If you don't have groups of 30 or more, if you have under 30, then you need them to tell you it's normally distributed. They did tell us right there. Normally distributed, right up here. All right, so let's go on. Q1, Q3, IQR. That's going to be exactly the same. Maybe I'll add a little page here to do that. Or I could just come down here. So Q1, you know what you need to do. Inverse norm, right? Inverse norm. And they're going to ask you area to the left. And that's going to be 0.25 because Q1, you're the end of the first quarter. Into the first quarter of a football game, basketball game, you're 25% of the way through the game. And they want you to have the mean, and the standard. The mean is same mean it was right here and right here, 13. Now, what do we do for the standard deviation?
You have to do the square root.
Exactly. Got to do the same thing we did right there with the square root because it's a group we're talking about, right? And then Q3 is going to be exactly the same. Inverse norm. But the only difference is for Q3, the area to the left is 0.75 instead of 0.225 because if you're at the end of the third quarter, then the game's almost over, right? You're 75% of the way through the game. And then you know IQR. IQR is just Q3 minus Q1. And so there we go. There's how we crank out all those numbers. Any questions I can answer on that one? All is well?